Okay, welcome to the deep dive. So today, we're tackling something pretty fundamental. We're going to challenge general relativity.
Yeah, Einstein's century-old theory of gravity. It's huge. And the source material we're diving into, it's called the Graviton Pressure Theory, or GPT, Part 8 of it specifically.
Right.
And it doesn't just suggest tweaking GR. It argues GR is, and I'm quoting here, structurally incomplete and causally opaque.
Wow. Okay. Strong words.
Very. The goal isn't fixing GR, it's arguing for a complete and irreversible break.
A break based on what?
On restoring causality, explicit cause and effect in physics.
Okay, so let's unpack that. This conflict. It sounds like two totally different ways of seeing gravity, right?
Exactly. General relativity, well, it treats gravity as geometry, mass and energy curves, space-time, and things just follow those curves. It's passive.
Like the shape of the space dictates the path.
Precisely. But GPT says, no, that's not it. Gravity is an active force, a mechanism. It comes from what they call anisotropic graviton pressure fields. Think of tiny things, gravitons carrying force, creating pressure differences that push objects around. It's active, not passive geometry.
So force versus geometry, that's the core split. But GR works so well, doesn't it? I mean, Mercury's orbit, gravitational lensing.
Yeah.
It nails those predictions.
It does. And that's GR's strongest point, its predictive power. But GPT's argument is that predicting what happens isn't the same as explaining why it happens mechanistically. GR says gravity isn't really a force in the normal sense. The math, like the Schwarzschild metric, it just describes the path in curved space. So the source calls it mechanically false, even though the math works out.
Okay. And GPT brings back the idea of physical force.
Yeah, it restores that intuitive picture. It says matter doesn't just passively curve space. It actively interacts with this graviton field, modulates it, creates pressure gradients. Cause and effect are back in the picture.
Whereas a GR, it tells you mass leads to curvature, curvature leads to motion. But the link.
Exactly, the how. How does mass actually make space-time curve? How does that curvature then make an object accelerate and transfer energy? GR doesn't really specify the mechanism. It's more of an abstract description.
Right. It describes the outcome, but not the process.
And GPT claims to provide that process, that causal transmission, through these active pressure fields.
Okay, so abstract description versus detailed mechanism. Let's see how this plays out with actual observations. Orbital dynamics. Mercury's weird orbit is the classic test case, isn't it?
It is. GR explains that tiny shift in Mercury's closest point to the sun, the perihelion precession, as a direct result of the sun's mass curving spacetime nearby. The geometry itself changes the shape of the orbit slightly over time.
Pure geometry.
Pure geometry via the Schwarzschild metric.
So how does GPT explain the exact same shift without curving spacetime, using pressure fields?
Well, it's all mechanistic in GPT. The precession comes from tiny ongoing variations in the graviton pressure the planet experiences. Think of it like subtle pushes and pulls from the field. These variations are influenced by things like the planet's own rotation, maybe resonance with other planets. It's a dynamic interaction with the pressure field. So the orbit changes slightly, not because the track is bent, but because the forces acting on the planet fluctuate in a predictable way.
Okay, so it's an active push-pull, not following a passive curve. Got it. Let's move out further to galaxies. This is where GR really hits a wall, right? The whole dark matter thing.
Oh, yeah. Galactic rotation curves. This is probably the biggest headache for standard cosmology.
Explain that for the listener again.
Sure. You look at spiral galaxies, and the stars out at the edges are moving way too fast. Based on all the visible stuff stars, gas, dust, and using GR's gravity laws, they should be moving much slower. They should be flung off, almost.
But they aren't. The rotation curves stay flat way out.
Exactly. So to make GR work, to provide enough gravitational pull to hold those stars in orbit, cosmologists had to invent dark matter.
Invisible stuff.
Invisible, non-interacting stuff that supposedly outweighs normal matter by like 5 to 1. It's basically a massive fudge factor added to the models because the geometry alone doesn't fit the observations.
But hang on, isn't GPT just swapping one unseen thing, dark matter, for another unseen thing, gravitons?
That's a fair question, but the GPT argument is that it's structurally different. Dark matter is an extra ingredient you add to the universe inventory list while keeping GR's physics.
Right.
GPT says the inventory is fine, you don't need extra mass. It's the physics, GR itself, that's wrong. The graviton field is the explanation. It's not an extra component.
How does a graviton field explain those fast outer stars then, without extra mass?
It's about the structure of the field itself. GPT proposes that the galactic core and the overall mass distribution create large-scale asymmetries and flow patterns in the graviton field throughout the galaxy.
Like channels or currents in this field.
Sort of. Stars orbiting in the outer regions are essentially caught in these large-scale pressure flows or alignments. They maintain their high velocity because they are constantly interacting with this structured anisotropic field pressure. It's the field dynamics, not extra gravity from invisible mass.
So the observation fits naturally within the theory, without adding something completely new and undetected like dark matter.
That's the claim. It implies maybe 85% of the universe isn't missing. It's just an artifact of using the wrong theory of gravity. That's a paradigm shift if true.
No kidding. Okay, let's switch battlegrounds. Time dilation. Another place GR scores big points, right? GPS satellites need those GR corrections.
They absolutely do. Clocks run faster further away from Earth in weaker gravity, exactly as GR predicts based on gravitational potential. The math from the Schwarzschild solution works perfectly.
Crucial for GPS accuracy.
Totally. But again, GPT asks why. GR says it's a consequence of the geometry. You're at a different height in the curved space-time manifold, so time flows differently.
But no physical mechanism for the clock itself changing.
Not explicitly within GR, no. It's just an outcome of the coordinates, the geometry.
So how does GPT explain a clock physically slowing down near a massive object if it rejects the geometry argument?
GPT connects it to the local graviton field again. It talks about local graviton pressure resistance and also field coherence.
Resistance, like friction.
Kind of. Imagine the atoms and molecules in the clock. Their oscillations are what we measure as time passing, right?
Atomic clocks rely on those precise frequencies.
So GPT says these oscillations have to happen within the surrounding graviton field. If you're deep in a gravity well near a massive object, the graviton field is denser, the pressure is higher.
Okay.
This denser, higher pressure field provides more resistance to those atomic oscillations, like trying to swing a pendulum through thick treacle versus air. The oscillations are physically impeded. They slow down relative to a clock in a lower pressure region.
So it's not just an abstract coordinate thing, it's a physical interaction. The clock mechanism itself experiences more drag from the denser graviton field.
That's the core idea, a direct causal mechanism. And it leads to a fascinating prediction.
Which is?
Coherence-based time modulation. Because GPT ties time dilation to interaction with this coherence-seeking graviton field, it suggests you could see tiny extra time shifts in atomic clocks if you place them in very specific, highly coherent electromagnetic or gravitational environments.
Environments GR wouldn't predict having an effect.
Exactly. GR only cares about the gravitational potential difference, the height. It wouldn't predict these subtle coherence-dependent variations. That's a potential experimental test to distinguish the theories.
Interesting. Okay, moving from experiments, the source material also criticizes GR's internal logic.
Yeah.
Calls them conceptual evasions.
Yeah, it argues GR isn't entirely self-consistent. One big point is what it calls Newtonian crutches.
Meaning?
Well, GR fundamentally throws out Newton's idea of gravity as a force. But in practice, for calculating things like satellite orbits or mission trajectories, physicists constantly fall back on Newtonian formulas and concepts.
Like using GMR to 2 year 2, we still use it all the time.
We do. The argument is that pure GR is often too complex to use directly for many real-world problems, so it ends up relying on the very force concepts it claims to supersede. The source calls this a structural confession, an admission it can't quite stand alone practically.
Okay, that's one point. What else?
Gravitational waves. This is a big one.
We've detected them, right? LIGO.
Yes, we've detected the effects. GR describes them as ripples in space-time geometry itself, carrying energy. But here's the killer question the source poses. If space-time, according to GR, isn't a physical substance, it's massless, it's just geometry, then what is waving?
If there's no medium, how does a wave travel and carry energy through it?
Exactly, it becomes a metaphor. The math describes energy propagating, but the physical carrier, the medium doing the waving, is undefined in GR. It's a conceptual whole.
How does GPT handle gravitational waves?
Much more simply, they're just high-speed pressure wavefronts, actual disturbances propagating through the physical graviton field, like sound waves through air. There's a medium, there's a physical process, no paradox.
And the last main critique, about math and reality.
Right. GR is accused of conflating its mathematical model with physical reality. It treats the curvature of its mathematical manifold as the cause of gravity.
Instead of just describing it.
Yeah. The source puts it bluntly. Mathematics is not substance. Equations describe behavior, they do not cause it. GPT insists on replacing that abstract causality with physical field interactions.
Okay, so summarizing GPT's proposed advantages. It provides causal explanations across the board. What else does it claim to restore?
A big one is the energy ledger. There's something called the conservation crisis in GR. Because defining energy locally in curved spacetime is tricky, energy conservation can become ambiguous. It's not always clear where energy comes from or goes.
That sounds like a fundamental problem.
It is. But GPT, by defining gravity as a net push from anisotropic pressure fields, makes energy transfer completely traceable.
How so?
When something falls, it gains kinetic energy because the graviton field is literally doing work on it, pushing it from higher pressure to lower pressure. The energy comes directly and accountably from the field interaction. It's conserved locally, no ambiguity.
That sounds much cleaner.
Yeah.
And you mentioned this leads to engineering possibilities.
Absolutely. This is maybe the most exciting implication. If gravity is just passive space-time geometry, as in GR, you can't really do anything with it. You just live with it.
Right, you can't bend space-time yourself.
But if gravity is an active pressure field like GPT proposes, well, fields can potentially be interacted with, maybe shielded, focused, or even generated.
So things like gravitational shielding or propulsion systems based on creating pressure differences in this field.
Theoretically, yes. Gravitational lensing in GPT isn't light following curved space. It's light refracting through varying densities of the graviton field, like light through glass. More like Snell's law. That implies you could potentially engineer materials or fields to manipulate that refraction.
Or real-time diagnostics of the field, too.
Potentially. It shifts gravity from being a passive background to an active, measurable, engineerable system. That's a huge philosophical shift for physics from just describing to potentially participating.
So this all comes down to what the source calls the final test, the questions GR struggles with.
Yeah, the core challenges GPT throws down. 1, what causes gravity fundamentally? 2, what's the medium for gravitational waves, if not space-time itself? 3, how does abstract curvature actually transfer physical energy?
And 4, why the reliance on Newtonian crutches?
Right. If the answers GR provides are evasive or metaphorical, the source argues, then the theory, despite its successes, is incomplete and needs replacement.
So the choice presented is stark.
It really is. Continue admiring the curvature of GR, this elegant, but according to GPT, causally opaque model. Or adopt a model like GPT-structured mechanistic causal that claims to restore energy accountability and, maybe, opens the door to actively engineering gravity.
Transforming gravity from something we just observe to something we might interact with. Shape even. That's quite a thought.
It's a profound possibility. Moving gravity firmly into the realm of engineering.
A fascinating deep dive into a radical challenge to physics as we know it. Thanks for breaking it down.
My pleasure. It's definitely a lot to think about.
And thank you for joining us on The Deep Dive.